Representations of rational functions. Learning outcome. At the end of the lesson, the learner is able to represent a rational function through its table of values, graphs, and equations, and solve problems involving rational functions. Lesson outline. First, table of values, graphs, and equation as representations of a rational function. Second, rational functions as representations of real-life situations.
Definition: a rational function is a function of the form where polynomial function, and this is not the zero polynomial. The domain is all value of x where qxd a zero. Average speed or velocity can be computed by the formula. Consider 100-meter track used for foot race. The speed of a runner can be computed by taking time for him to run the track and applying it to the formula, since the distance is fixed at 100 meter. Example 1. Represent the speed of a runner as a function of the time it takes to run 100 meter in the track. Solution. Since the speed of a runner depends on the time it takes to run 100 meter, we can represent speed as a function of time. Let x represent the takes to run 100 meter, then the speed can be represented as a function x as follows. Sx equals 100 over x. Conserve that it is similar to the structure to the formula S equals d over t, relating speed, distance, and time. Example 2. Continuing the scenario above, construct a table of values for the speed of a runner against different run times. Solution. A table of values can help us to determine the behavior of a function. As the variable x changes, the current world record for the 100-meter dash in 9.58 seconds, set by Jamaican Usain Bolt in 2009. We state our table of value at 10 seconds. Let x be the runtime and Sx be the speed of the runner in meter per second, where Sx equals 100 over x. The table of value for runtime from 10 seconds to 20 seconds is as follows. From the table, we can observe that the speed decreases with me. We can use a graph to determine if the point on the function follow a smooth curve or a straight line. Sample 3. Plot the point on the table of value on a Cartesian plane. Determine if the points on the function Sx equals 100 over x follow a smooth curve or a straight line. Solution. Assign point on the Cartesian plane for each entry on the table of value above. Plot point the Cartesian plane. By connecting the point, we can see that they are not collinear, but rather follow a smooth curve. For the 100-meter dash scenario, we have constructed a function of speed against time and represented our function with a table of values and a graph. The previous example is based on a real-world scenario and has limitations. The values of the x variable, for example, a runner cannot have negative time, which would mean he is running backward in time. We can apply the skill of constructing table of values and plotting graphs to observe the behavior of rational function. Example 4. Represent the rational function given by f of x table of values and plot a graph of the function by connecting points. Solution. Since we are now function is general, we can find function values across more values of x, let us construct a table of values for some x values from -10 to +10. Plotting points on a Cartesian plane we get. Connecting the point is this graph we get. Why would the graph unexpectedly break the smooth curve and jump from point E to point F? The answer is that is just not. Let us take a look at the function again. So, we will cover this aspect of graph of the original function in a future lesson. So for now, we just present a partial graph for the function above as follow. Example 5. Represent the rational function f of x minus x to the power of 2 negative 3 x to the negative 10 over x using a table of values. Plot the point given the table of values and sketch a graph by connecting the points. Solution. As we have seen in the previous example, we will need to take a look at the x values which will make the determinator 0 in this function. X negative 0 will make the denominator 0. Taking function values for integers in -6, we get the following table of values. Plotting the value above as points in Cartesian plane. We connect the dots to sketch the graph, but we keep in mind that x equals 0 is not part of the domain. For now, we only connect those with values x less than -1 and those with values x greater than 1. The behavior of the function near those values which make the function undefined will be studied in the next few lessons. Example 6. In an entire barangay basketball liga, the team from Barangay Colyart has won 12 out of 25 games, a winning percentage of 48%. We have seen that they need to win 89 games consecutively to raise their percentage to at least 60%. What will be their winning percentage if they win? A. 10 games in a row. B. 15, 20, 30, 50, 100 games. C. Can they reach a 100 winning percentage? Solution. Let X be the number of wins the Barangay Collier needs to win in a row. Construct a table of values for P. We interpret the table of the values as follow. Even if the team wins 300 consecutive games, the team still cannot reach a 100% winning percentage. Note the denominator 25 plus times x greater than denominator, so 100% cannot be achieved. This is reasonable since the team has lost 13 games already, so they cannot be perfect. Example 7. 10 goals were set loose in as island and their population growth can be approximated by the function, where p represent a goat population in year t since they were set loose. Recall that the symbol denotes the greatest integer function. How many goals would there be after 5 years? B. What is the maximum gut goat population that the island can support? Then evaluate the function for solve example given. A. Construct a table of variable using the number of from -2 to 8. B. Plot the point in the Cartesian plane and determine whether the points from smooth curve are a straight line. B. Plotting the point, we get the following. This is the solution of this. Connecting the points, we get the following graph which from two different smooth curves. Constructing the table of values, we see the function f of is undefined at the x equals 1. If we plot points and connect them, we will see that we can only connect those with values x less than 0 and those with values x greater than 2. So we can say that it disconnects at the interval 0.2. Similar to letter A, we see the gx is undefined at x equals -1. It disconnects at the interval -2 and 0. A hypotensional function representing the concentration of a drug in a bioregimes of time is given as A. Construct a table of values. B. Plot the points in a Cartesian plane and connect them. C. What can you say about the function? Solution. A. Since t is in time, we can only use non-negative values for it. Using the first 10 whole numbers we get. Plotting the point and connecting them we get. C. The concentration is 0 since drug has not entered the bloodstream yet is shot up at I but start decreasing after that. Lesson 7 Supplementary exercise. First, construct a table of values for the following function using the integers from -4 to 4. A. F of x equals 6 over x negative 2. B. Rx of equals 6 plus times plus 12 over times to the power of 2 negative 4. 2. Using the table of values got from the previous question, plot and connect point of CFX ERX. 3. A certain invasive species of fish was introduced in a small lake and their population growth can be modeled with time t by the function ft equals 1000 plus 1 over plus 10. A. Construct table of values. B. Is their population approaching a specific values?
Representations